Good afternoon, ladies and gentlemen. It's great to see that still many people are around. There are two potential reasons for that. So one was the advertisement from Michel. Might be one of the reasons. By the way, where's Michel? Ah, bad luck, bad luck. I will tell him afterwards. Second reason, probably more importantly, we have a list of very high potential panelists here. We have a lot of interesting topics, hands-on topics. I think that adds value to the conference, and you should be, let's say, enthusiastic and expecting a lot. I'm expecting, by the way, also that we jump over the hurdle Michel raised. Anyway, first of all, I would like to ask you to welcome the panel. Yeah, thank you. So what I took with me from yesterday was one sentence. We have not enough Spaniards in our environment here. I fully agree with that. Yeah. So, but luckily, we have two Spanish specialists here in the room, and best qualified to present here. It's Jaime Pereira from ADEF and José Antonio Quintano from CAF. Well, during conferences in former better times, let's say, but good times now start again, we heard a lot about the big success and investment in the Spanish high-speed network. So this is certainly a huge success story. But there is more to tell about the Spanish ERTMS strategy. And this is about what Jaime and José will tell us. So this is to explain how and where ETCS could be used in regional networks and on commuter lines. So that's showing us that there is more than high-speed lines, conventional lines, where we can use ETCS. ETCS is highly scalable. So I'd like to give you both the floor and present the topic. Thank you.
Okay, thank you, Klaus. Good afternoon, you all. Okay, we're going to talk about ERTMS on the Spanish commuter lines and regional as well. We'll start by explaining a little bit our network development plans and also our vision for commuter and regional networks, very much based on performance and sustainability. After that, José Antonio will explain some issues more in the technological side. He will share with us some return of experience and also some proposals. Okay, here you can find our strategic plan 2030, very much based on sustainable development goals. We put people at the center, and thus we want to improve mobility, among other things, by enhancing the use of our network. We lean in 4 different pillars, namely safety, service, sustainability, and performance orientation. And we use some levers such as digital transformation. And for us, ERTMS fits perfectly for these purposes. To translate these overall strategic goals into figures, a significant amount of money is being allocated in improving our existing network. I would like to remark that this amount of money is higher than the money we are investing in new infrastructures. And Well, that's a game changer for us because it wasn't like that in recent years. Within this strategy, commuter networks play a key role to boost urban mobility. And of course, ERTMS is taking a good part of those investments. Well, Klaus, I think you're right. There's kind of false preconception about ERTMS in Spain focusing only in high speed. And, well, it's not like that. We've been rolling out ERTMS in for some other issues since many years ago. What you can find here is the most relevant commissioning milestones for the upcoming years. By the way, we cooperate with different technological partners for these projects, not only our dear colleagues from CAF present today. I would like to also remark that for some of these projects, such as Mediterranean Corridor, among others, will definitely benefit from CR 1357, that stands for Eurovalleys on 3 rail tracks, and it will be included in the next CCS TSI. For NADIF, we will really want to thank both the agency and UNISIG for the cooperation in the frame of this CR process. Essentially, these projects are level 2 projects in Madrid and Barcelona commuter networks and level 1 projects in conventional lines. Roughly, we'll make 500 new level 1 kilometers and around 450 new level 2 kilometers for our network. Yesterday, it was really great to hear from Kierfits that the Commission is planning to revitalize regional lines. It's great because we are very much in the same page. We are seriously considering to equip low-density lines with ERTMS, bearing in mind that there's a need for CCS renewal in some very old lines. All of us, we know that future is radio-based, and we plan to develop some pilot initiatives focus on radio-based ETCS plus fail-safe train positioning and digital map, trying to simplify trackside equipment as much as possible. But we also know that we will have to wait some more years for FRMCS products in the market. So, in our view, that means that for eventual short-term needs, simplified level 1 solutions could still be an option. Of course, our vision for all this strategy is to have equal ramps, meaning similar ramps than the one we have for the big projects, but making more sustainable, because, well, those lines are not that much used and we cannot afford such a high cost. And, well, that's all from my side. I will give the floor to José Antonio. Please.
Thank you, Jaime. Good afternoon, everyone. I would like to continue this presentation sharing some experiences implementing ERTMS projects on these regional lines. Sorry. Yeah, that's better. Sharing some of our experiences in implementing ERTMS projects located on these regional lines mentioned by Jaime in his presentation, and also our vision about new elements that could be introduced on these regional lines on the short and the long run to make this more sustainable and performing. And all of this in 7 minutes, so I should start. Concerning existing and ongoing projects, we are currently working on the Vigo-Redondela line on the northwest of Spain, part of the Atlantic axis, and also on La Encina-Valencia, which is located on the east coast of Spain. And even though these two projects have some differences, they share some similarities. Basically, both are ETCS level 1 overlay projects over existing and in-service installations, signaling installations, including a Class B system, a Spanish Class B system. And both are basically brownfield projects. So it has some pros and cons. So first, any ETCS overlay need to cope with a line not specifically designed for ETCS. So several elements need to be engineered accordingly, taking into consideration, in one hand, ADIF's engineering rules, and also existing constraints like signal locations or track circuit joints and electromagnetical compatibility with Class B and this kind of stuff. As well, being in service, being in commercial service, these lines, the new equipment and assets needs to be installed with no or very limited disruption to the line. So night shifts are very commonly used. Another usual constraint is related with civil works and reuse of existing cabling ducts, which are usually heavily packed. So occasionally you can find difficulties to deploy new cabling. For this reason, LEOs are being installed and on distributed cabinets along the track. But also to reduce the distance between LEOs and ballast group location, minimizing on the process the use of C cabling. On the bright side, being already in line, these lines in operation, track auscultation and track topology data can be obtained from the very beginning, and this data is very accurate. So ETCS data preparation and configuration are more reliable and require less iterations to be ready for testing and validation. Main challenges. Well, while Atlantic Axis project has only passenger services, La Encina-Valencia has a mixed traffic of passenger trains, commuter-like trains, plus occasional freight services. ETCS characterization of all possible equipped trains that will run on the line is not always easy to get, and it creates additional challenges for ETS parameterization. But on this ETCS overlay project, not only ETCS needs to be adapted to the existing line, but also interlocking itself may need several modifications. The first, and probably more important, is to enable an interface between interlocking and trackside ETCS, allowing the implementation of necessary functionality. This is not exclusive of level 1. This is also for level 2 or level 3. For instance, in the Vigo-Redondela line, ETCS products had to interface with existing interlockings in service. On this section, the interlockings were from the same supplier. But not being these interfaces standardized, in other cases, depending on the interlocking type and supplier, it would require to implement tailored solutions and represent a fundamental obstacle sometimes for mixed supplier installations. Sometimes interface between interlocking and the adjacent interlocking need to be updated to give more information about entering and exiting routes and allow smoother transitions and longer MAs on the borders. And not only interfaces, but also internal parameters of the interlockings need to be updated as well, like timers, usually to accommodate new braking curves. And that's it for the experiences, and some very shortly ideas for the short-term and long-term proposals. So for the short-term, well, we all know the benefits of radio-based ETCS. It has been said several times during the conference. The benefits in terms of digitalization possibilities, in terms of better performance, and we all hope that it will be the seed for the starting point for the architecture in the system pillar. Of course, we are all in favor of this level 2 and level 3 when possible. However, as mentioned by Jaime today, a number of regional lines in Spain, especially low-density lines, will need to be renewed in the next years. For this type of lines, where business case of a radio network deployment is very difficult, a fully compliant yet simplified ETCS level 1 can be used and apply. There is a combination of techniques or ideas that can be used, but very shortly. For example, the use of a simplified and optimized ETCS rules, not only to reduce the number of values grouped, but also to make data preparation simpler and faster, and consequently more cost-effective, simplifying the testing and validation that can be used, among other ideas. So in this last minute, three new proposals we are investigating, or we would like to investigate in the coming years. As mentioned previously, one of the biggest issues for ETCS overlay project is related with lack of standardized interlocking and ETCS interface. Well, not only for regional lines, but for all kind of lines, actually. There are hundreds of state-of-the-art interlocking in service being installed or under tendering process across Europe today, which are suitable candidates to be overlaid with ETCS. This is a challenge that needs to be properly addressed in the future CCS architecture and assessed as part of the migration strategy. We need to preserve the investment. So how can we make the most of the installed base of interlockings? So a standardized, even interport interface will help to preserve the investment, bringing more competition and avoiding vendor locking situations. There are other type of interfaces like level crossings with ETCS that can be explored, and we can benefit from, well, this kind of interface will allow the integration of these assets, very usual and on regional lines, to improve safety and operation. The second idea, and I'm out of time, in the context of regional lines and the need for cost reduction of ETCS system, the evolution of current train positioning plays a key role. We are supporting an innovative system to calculate train absolute position based on GNSS, inertial measurement units, speed sensor, and digital maps. The system shall be able to feed multiple applications, not only ETCS, within the train, providing continuous absolute positioning. Finally, as mentioned before, radio-based ETCS is the future, no doubt about that. And regional lines should also benefit from using ETCS level 2 and level 3, and FRMCS has a potential to help in this direction. Maybe a low-density regional line cannot afford a 5G dedicated network, so we should investigate alternative access network like public MNOs or high-frequency technologies available for infrastructure manager, and not only for vital communication, but also for any kind of service. That's it. Thank you very much.
Yeah, thank you both for this very informative presentation. Again, underlining how flexible ETCS could be in its application. So, for regional lines, which are certainly more price sensitive, for commuter lines, tendencies more towards high density, high performance. So different applications, but all could be covered. By the way, this is not an exception in Spain. We see that all over Europe, ETCS is growing into different domains, which is good. Good. As next speaker, I would like to welcome Ralf Kaminski from Siemens. So he will provide a supplier view on level 3 and ATO. And his presentation includes different aspects regarding where we are today with level 3, with ATO, what are the challenges, what are the benefits for these two important game changers.
Yeah,
Ralf.
Thank you, Klaus. So, as you said, my name is Ralf Kaminski from Siemens, and I was asked to give some impressions about the experience with ETCS level 3 and ATO. And when I took this course, I first found out it was two topics, namely ETCS Level 3 and ATO, which is combinable, but principally two different things. So I will start with what we have kind of experienced with Level 3 and hybrid Level 3 especially. And therefore I will start up to remind us what was the original concept of ETCS Level 3. The classical view of this ETCS Level 3 has involved trains operating in moving block on a track that has no track vacancy detection, so TVD, and no signaling aspects. That means that rather than rely on fixed block TVD equipment, trains would instead be located only via their position reports to the RBC and operating in moving block. Train integrity monitoring would ensure that the train remains complete and the position can be fully trusted. That was the original concept. And as you can imagine, a lot of challenges go with this technical concepts. So in particular in mainline railways, so if there's no TVD, then a loss of communication with a train means that the only source of safe train location information is lost. The movement of unfitted vehicles and wagons cannot be detected. That brings us to the next point. All trains, including freight trains, must be able to monitor their train integrity, so a mixed traffic with legacy trains or unfitted trains is not possible. Hybrid Level 3 overcomes these challenges by retaining limited track vacancy detection equipment. Even after loss of communication, train movement can still be tracked via TVD. The presence of ETCS unfitted trains or vehicles can be detected via these remained TVD, and ETCS fitted trains that are unable to report their integrity, however, can still run on the line, however with reduced capacity, but it is possible. For hybrid Level 3, the physical TVD can be subdivided in several virtual subsections, VSS, and these virtual subsections unlock additional capacity for ETCS-fitted trains. The trackside determines the occupancy state of each virtual subsections by safely combining position reports, train integrity, and safe train length from ETCS onboard equipment with the information coming from the TVD equipment. So this idea, we followed this idea for a longer time, not only we as company, but in the industry sector. So we did trials in 2016 and 17, mainly in UK, in the ENIF laboratory and test track, and made a demo in 2018, combining ATO with this hybrid Level 3 concept. And in 2018, the X2Rail project, Shift2Rail, X2Rail 1 moving block project, was able to present a demo at InnoTrans in 2018. Unfortunately, the InnoTrans couldn't take place in 2020, but it is foreseen to have another demonstration of the latest results from the X2Rail 5 project in the InnoTrans, and showing the integration of moving block and adaptable communications and train integrity demonstrators. A operational use of this is foreseen in a project in Norway, where it is foreseen to use this hybrid Level 3 on dedicated and selected lines from 2024 on. So the benefits of hybrid Level 3 are mainly on capacity and enables operation with fitted and unfitted trains. So it is a good intermediate step to full level 3. Of course, there are challenges needed for further standardization for operational and trackside behavior, because it really depends on the operational rules of the infrastructure manager how to deal with certain operational incidents. And one important topic is that the safety targets for the subsystems, like the train integrity and so on, needs to be clearly defined, because we have new elements in the entire system. Of course, the safety overall shall remain as it is usually in our signaling area. So our wish is that we continue working on this alignment of all these specifications under the umbrella of the ERJU to get a common approach for this hybrid level 3 topic. That brings me to ATO, which is a different topic, as you know. And we heard a lot of about ATO in this conference already. And ATO over ETCS is the element which really brings added value to ETCS in the direction of in the direction of the target setting of the European Green Deal, as on the operator needs, with capacity increasing, availability increasing, and so on. Many of key benefits are there with ATO over ETCS, like improved network operation performance, enhanced transport capacity, stopping accuracy, timetable stability and punctuality. So, and the other ones, of course, as well. And also on ATO, we heard in the workshops very well the history of the specification works, which was presented there by Benoit Bienfait, very detailed. And the experience, what we have there already in projects is the one in Hamburg, the S-Bahn in Hamburg, where we have ATO over ETCS in operation on a dedicated line. And there will now come new projects around Stuttgart. We heard about Stuttgart already here, where these ATO over ETCS will be an essential part of the equipment. And then afterwards, we see already tenders in preparation in networks and lines where this will be required. I talked about the history. As I said, in 2018, the first specification was aligned with within the Shift-to-Rail project. And now we have the situation that the latest specification will be introduced in the TSI 2022. And we expect then a wide rollout of this technology. ATO over ETCS, from our point of view, and what we heard and what we saw in the tests and in the pilot lines, is that it really considers the interests of the majority of all stakeholders. That is quite interesting. In the field, we have the interests of network providers, of operators, and the operators in mainline, as well as in the passenger area, and in shunting yards, or yards as well. And of course, the vehicle supplier is happy if we can deliver more performant vehicles and systems to our customers. And the most important topic is that ATO unleashes the full benefits of interfacing to traffic with interfacing to a traffic management system. So I always say the trains can better run as calculated, so to say. When traffic management system and the timetabling process gives a optimized or calculates an optimized driving regime, then the train with the aid of ATO can directly or better follow this regime as without ATO. So it optimizes, it is possible to optimize the traffic flow network-wide for maximum possible throughput on the one hand, and on the other hand, it is possible to reduce energy consumption and mechanical wear and tear of the vehicles. And in cooperation and standard interface between this, as it is written there, it unleashes the full benefits. But it needs a cooperation between the network operators and the vehicle operators, because there might be differences in target setting. The one hand is keen on having maximal capacity. The other one may be interested in more in energy saving. So it will be interesting to see how these things will balance to each other. This one I skip. So as I said, the key benefits for ATO over ETCS is a reduction of energy consumption, standard interfaces between trackside and onboard, ensure the interoperability, and the increased punctuality and capacity by train run automation, ensure optimized train runs. Also there, even the specification is fine and valid for the TSI 2022, we still have some challenges. So, of course, ATO needs ETCS as backbone as it is described now. And there are some things for further investigations needed. For example, the adhesion management, especially for freight trains, where we have an unknown composition of traction force and train weight and length and so on, and braking performance. And therefore, further investigation is necessary to optimize these algorithms which steer the trains. So coming into the end and combining both. So as I said, ETCS hybrid level 3 has benefits about capacity and using existing infrastructure and being applicable on existing infrastructure. Yes, there are challenges with full alignment and common vision about the future usage and operational cases. ATO has benefits for the railways as well, capacity and energy consumption. We are looking forward to have and to realize a harmonized roadmap for coordinated ATO rollout. And the last one, if we combine both, so studies show that with a combination of ATO and hybrid level 3, we can significantly increase the train run capacity on existing lines, and so follow the demands of passenger and freight operators. Individual simulation for the use case is needed for that, because it is a system with many screws on where we can turn on, but it is possible. And the final sentence I would like to say is that for the planning of the operational concept, already there, we should think about that journey profiles for the ATO are generated in order not only to plan the operation on the paper, but also already consider there the operation in the field in the next last step. That's it.
Thank you, Ralf, for highlighting the operational economical impact of ETCS level 3 and ATO. Interestingly, well, my small recommendation, you were almost perfectly in time, but you have to probably fine-tune your ATO for the presentation mode a bit, but it was almost perfect. Yeah, well, there are interesting there's one interesting difference between level 3 and ATO. From my point of view, both have operational benefit, of course. The thing with level 3 is that the infrastructure managers primarily will benefit with more capacity and less infrastructure. There's some additional effort on the rolling stock side. Whereas regarding ATO, also railway undertakings directly benefit with less energy consumption, lower cost, etc. So that's the good point with ATO. But of course, if we can combine them, this is much more than that. Good. So next point on the agenda is a report from the workshop number 4, feedback from ATO from earlier implementations. So, well, I have to thank Christoph in particular, because he jumped in, he stepped in for somebody who at last minute could not make it. So Christoph González Alpuim from DB is so brave to summarize in 5 minutes max what the result of this workshop number 4 was. Thank you.
Thank you very much, Klaus. Yes, I'm very happy to present to you the results from workshop number 4 about the implementing of ATO over ERTMS as an early feedback from implementation. I will keep it short and simple, 5 minutes. And Ralph also already told us how the functions are from ATO. So first of all, ATO over ETCS or ATO over ERTMS is already in passenger service in Hamburg, as we can see. So if you look back what we have already accomplished, we can see that we had already laboratory tests with, for example, Alstom, CAF, Siemens, Thales, also AGD, here missing as a company, are already finished with different test benches, so that the interfaces between the components of ETCS onboard with ATO onboard and ATO onboard with ATO trackside are already functioned with the current subsets. We have also first pilot tests, pilot projects in the UK with passenger services, and also Switzerland with freight. They are also already finished, where we have a lot of information that we got for the development of the subsets, and therefore also for the next topic here. We had a very successful implementation of ATO over ETCS in Digital S-Bahn Hamburg. In Hamburg, you can see here a picture of the train that is moving, that could move in automatic mode. So we have here TSI CCS 2022. It delivers for us the relevant requirements for ATO over ETCS in GOA2. So therefore, we can say ATO GOA2 is mature, is already in passenger service, and is ready for rollout in Europe. So what's next, you think? And what we should do now, or what are our next steps, is firstly, we want to develop a standard architecture for ATO GOA4. It's a big step to make from GOA2 to GOA4. I know it from our proper project that GOA4 does require a lot more requirements related to GOA2. And secondly, what we are looking for is a first ATO GOA4 demonstration here coming in January 2023. So we are looking forward to that for the development of ATO, and yeah, thank you very much.
Thank you. Yeah, now, well, I heard it also yesterday, some call Denmark a small country. I won't do that. But Denmark is definitely a positive example regarding ETCS rollout. So they started a complete entire network rollout in Denmark, which is worth to be mentioned. So here we have Jens Møller from BDK and Christian Löffler from Thales. They will not explain the entire ERTMS program, but focus on level crossings. You might now say, well, this is just an element, but it's an important one even for level 3, etc. So even in the future for future systems, level crossings will play an important role because, well, it's just too costly to eliminate them all. So there's a natural conflict in terms of performance. There's, of course, safety, an important impact here, important parameter. So the question is then how to manage level crossings with ETCS level 2, probably extendable to level 3 as well, radio-based, which is important. So we should give now these two colleagues the floor and enlighten us how we could manage level crossings in an optimal way. Thank you.
Thank you, Klaus, and good afternoon, ladies and gentlemen. First, a bit of context. As Klaus says, I come from the Danish signaling program, as we call it. It's an ERTMS-based program, but it's more than just ERTMS, of course. And what we have chosen as topic today is the integration of level crossing protection systems. We have quite a few of them, as we have a mixed railway in Denmark. I'm going to just introduce the context, and then later on my colleague Christian from Thales is going to talk something about the actual implementation of level crossing protection systems in the West contract, which is half of Denmark. So what is the Danish ERTMS deployment, or signaling, re-signaling deployment? It's the national network of the Danish railways, 2,100 kilometers of mixed operation railway, which is being converted as we speak to ERTMS level 2 without line-side signals. We convert from a mixed situation of color light signaling with the ATP, classic national system. And what we are doing is we are replacing everything from traffic management layer and to the track, to the objects in the track. That includes level crossing protection systems, and it also includes just about anything else signaling related. So we are introducing a digital signaling system. The way we did it was we signed design, build, maintain contracts with two suppliers, Thales, who's with me today, and Alstom, to replace signaling systems. In these replacement, we have today 400 level crossing protection systems that will be replaced with new level crossing protection systems integrated with ERTMS. Just 10 years ago, we had many, many more level crossing protection systems, or level crossings, I should perhaps rather say, because not all of them were protected at all, and some were very simply protected. With the new systems, we have a unified model, unified protection level, and this is what we're going to look at today. Level crossing protection. It's a protection system where we need to find a balance, because it's where railway and road meets. Normally, we have level crossing protections mainly on secondary lines, but we also do have some on main lines. And on main lines, we typically have a higher line speed, 140, sometimes even 160 kilometers an hour. And this is a bit of a challenge, of course, with level crossing protection systems. You need to find a balance between blocking the road and blocking the railway. And this is where ERTMS comes in play as a radio-based signaling system. There are new opportunities compared to the national systems. We have looked at, and Christian will talk about, how we are using speed-dependent activation of level crossings based on the MA request. At the end of the day, it's a configuration, so Bane Denmark, as the infra manager here, can choose the activation scheme for per level crossing at the TMS level, and in this way we can find the most optimum solution for each level crossing, and this is being used. Obviously there are challenges here for level crossing protection systems with road clearance sensors. You cannot just close the level crossing if there is something detected that blocks the level crossing. So this is a challenge for scheduled operation of things. A last thing to mention from an operational point of view is that we have chosen a configuration where the speed over an unprotected level crossing, so in order to approach, is set to 10 kilometers an hour. In our case, we know of cases in other countries where it's 0, so you have to stop. If you do that with the braking curves we have, then it would be very difficult to approach the level crossing protection systems. So, with this, I will hand over to Christian, and
thank you very much, Jens. So then let's have a look, a quick look onto the solution. So it is very obvious that you have to connect the level crossing somehow to your central signaling system. We are doing so by connecting them to our interlogging. So we have, on the one hand, the current status of the level crossing in our central system. And on the other hand, of course, we have the possibility to trigger the closing of the level crossing in time. So the main principle of the solution is that we always submit the current state of the level crossing with the help of the level crossing information packet, packet 88, to the train. So then we are always on the safe side. The train incorporates, if the level crossing is not protected, a speed restriction into its most restrictive speed profile. And on the other hand, for the driver, there is an indication in case the level crossing is not protected, so that you can install some operational rules so that the driver is aware of the not protected level crossing in the case it is not protected when the train reaches the level crossing. So this is the main principle. We are sending this information always to the train. And now, how does it work to optimize the closing for the level crossing? Because, of course, we are doing our best to close the level crossing in time. So the principle is really simple. So when the train approaches the level crossing, it gets a movement authority covering the area of the level crossing, which is at that time, of course, not yet protected. The train continues to move forwards to the level crossing and will send MA request based on its end of authority, EOA. So, and due to the selected MA request parameters, they ensure that there's, when we get a movement authority request, there is sufficient time to trigger the closing of the level crossing so that the level crossing is closed in time before any indication is displayed to the driver, as well as before any brake application is done by the ETCS onboard unit. So unfortunately, we had to withdraw this concept, this simple concept. So what I've presented now, it was a paper-based version of our solution. The reason is that according to the specification, it is not 100% crystal clear that we really get a movement authority request for the temporary EOA, which is at the level crossing. So the level crossing, which is unprotected, it is clearly specified that it's a temporary EOA, but it is not crystal clear that we really get an MA request in all the cases, at least not in system version 2.0. So how to solve that? Okay, we just placed the marker board, a real EOA at the level crossing, so that in principle we can use our algorithm and reuse the MA request, only that it is now based on a real EOA. Since the MA request but is not fully based on the estimated speed, and it also does not contain any estimation up to the level crossing, we need to further optimize. So we can use the MA request as a base, as a trigger, but we have to do further optimization. And this is done by our traffic management system. So we give the possibility to configure a specific delay or specific delays depending on, for example, the topology, depending on the timetable, depending on the max train speed, and of course also depending on the level crossing type, if it's half barrier level crossing or full barrier level crossing. So this is configurable in our traffic management system, which at the end triggers the interlogging to close the level crossing. Yeah. So now the train is approaching the level crossing. The routes are set fully independently from the level crossing status. And first of all, the train, of course, gets a movement authority with the information, with the level crossing information packet, that the level crossing is not protected. So it has a level crossing speed restriction on board. The train continues to approach the level crossing. Our introduced delay of the activation of the level crossing at the end triggers the closing or elapses, and then this is a trigger to start the closing of the level crossing. And then when the level crossing is finally closed, we can, or with the help or with the information we have in our interlogging, this information is transferred to our RBC, and with the help of the RBC, we can remove this level crossing speed restriction to have an aligned view also on board that the level crossing is now protected. So what happened next? Okay, the train continues to drive. It passes the level crossing, of course. The track section for the level crossing is cleared. Everything is okay. So finally, the clearance of the track section is the trigger to reopen again the level crossing. So, of course, the system has to detect that this unprotected level crossing is done by a sequential train movement. Klaus, I have 2 minutes left. Okay. So, okay. The system detects that the clearance of the track section was done by a sequential train movement. Everything was okay. So we don't send anything to the train because it has passed the level crossing. Everything is okay. So everybody was happy. There was some party in the train. Nevertheless, what happened next was that we sent an MA extension to the train. And this MA started at the LRBG, which was in rear of the level crossing. And so it covers again the level crossing area and our simple principle. So whenever there is an information inside the area of an MA, sends the state to the onboard unit, now leads to the fact that the train gets again a movement authority and a level crossing speed restriction, which was already passed by the train. Okay, but this leads to a trip of the train. Okay, it's fully specified in the specification that this is the wanted behavior, so no doubt about that. But I think Jens was not fully happy with the solution. We introduced a small mitigation. So we had a short-term solution. We placed a balise group directly beyond the level crossing. So the new movement authority starts now at this balise group. So the level crossing speed restriction is not anymore in the level crossing. Fine. And after that, we introduced also a change in the RBC. And we took this RBC software out of our Thales Play Store, installed it at the customer side, and now we have also a solution in the RBC. So, and now a dangerous question. Does this solution fulfill the operational requirements from your side?
You could say this was not the optimum solution, but it is definitely a working solution. And it gives an acceptable performance. There are potential, of course, in doing something better. And if you look at the general blocking time performance, I think this is okay. The flexibility of fine-tuning, it's okay. It delivers the performance we want. But there are possibilities to improve this. The MA request is more well-defined in system version 2.1. So if we upgrade it to 2.1, we could get a better performance of this. And of course, for the future as well, if we introduce, when we introduce ATO on top of level 2, then you have the journey profile. You would be able to activate based on better dynamic criteria. So there is a development path for this. We can do it better. But what we have now is a good deployable solution, and we have it deployed on many level crossing protection systems in Denmark today, and it works.
Yeah, excellent. Thanks, Jens and Christian. Well, and let us accompany somehow the process of developing a solution, which is, I have to confess, pretty technical. But anyway, it's good to see that there are some guys knowing what they are talking about. So before you start to reinvent level crossing solutions, please then get in touch with Jens and Christian. They know what it is about. Yeah, even though it looked at first glance complex, well, level crossing, open, close, the takeaway is, well, level 2 ETCS radio-based probably is helping to address the topic. So again, thank you very much for you both. The next point on the agenda is a complicated one, a completely different angle, not technical but operational. We talk about operational harmonization since years, if not decades, that it's important, but well, we know that is root cause for complexity and cost, but we know as well that it's difficult to achieve. So how to get there? Yeah, we all accept that it's important. And Michael Leining from NextRail, Danilo Iovino, they work from Hitachi. They work already since a while on that topic, both together in the ramp-up project, System Pillar ramp-up project. Well, probably they will not tell us that the work is done already, but we're at the starting point. But there is an idea how to do that, and that's important. That's about the process. We could not accept that next year in January everything will be settled, but we're coming there. So they will explain us the approach and what we need to do. Thank you in advance.
Thank you, Klaus. Ladies and gentlemen, yeah, a good introduction. Took half of my introduction away, but that's fine. Doesn't matter. So I will give you a rough picture of what this project is about, and Danilo will be happy to take you to our workbench and show you how it works. But of course, the big picture is very important, and perhaps one personal remark, it's like 13 years ago I stood on a stage like that, and I hear me just saying, I don't believe in operational harmonization in this century. So now I'm standing here and trying to tell you that it works, and we are convinced that it will work, and how it will work we'll try to show you. The goal of today is not to give you at the end a rule book at the exit and you can go home and implement that right away with your operations. That's not the goal. We are talking about a meta process that we developed that enables us to go into operational harmonization, and we happy to admit that operational harmonization works within a technical target picture, within an architecture that we've been talking about also yesterday, having some game changers on board. So our prerequisites are like, we are talking about a radio-based ETCS without line-side signals. We are talking about ATO GOA 2 or more. We are also presuming that we have a very accurate train-borne localization. We have train integrity on board, and of course, many discussions also today, FRMCS as the communication basis, as a radio system that we have. And there are some other architectural technologies and designs that we assume to be there in our target picture. And for this target picture, we are thinking about how that could work, that we come to an operational harmonization. And the overall idea or our assumption at the moment is that it will work, and but we have to come to this common architecture, modularization, standardization of interfaces whatsoever. So what we did so far is describing this meta process. What we did so far is some proof of concept. So we've taken like 6 scenarios that we analyzed, and with these scenarios we developed a documentation, easy to read and a very extensive prosa documentation that we've worked out, and Danilo will take us to the workbench in a minute. So as we are working within the ramp-up phase of the system pillar, as Klaus mentioned, we are relying on a few input documents that we have been analyzing and that will be also the input to the system pillar phase. The first document is simply a comprehensive paper about the operational concepts for CCS Plus. And you've already recognized we are only talking about CCS Plus and not more. And in that document, there is the methodology, how we document, how we come to the further processes and derive our scenarios. What we've been dealing so far as an input are the scenarios with start of mission. We started with that because some of you may remember we had this discussion 3 or 4 years ago that we had like 17 different start of mission procedures in Europe. So we thought it might be worth looking first of all to that start of mission procedure, and we can tell you that within these harmonized architectural technological picture, it's quite easy to describe such a process. We looked at passing a level crossing, fits to the presentation just before us. We looked at emergency stop, loss of integrity, and we're taking, of course, valuable input into account from links for rail and from extra rail. Those of you dealing a little bit more with the system pillar may have recognized that the system pillar core group issued a concept paper on operational concept. That's primarily dealing with everything around us, around CCS Plus, and we are concentrating strictly on CCS Plus, and of course have to work together with the other domain led by Davinder Bhatia and Björn Lietzen. Domain is architecture and migration, where we are talking about the actors and the capabilities and the functional apportionment. And later on in the system pillar phase, we will also have to collaborate with task 1, so all the processes around us. And if you read the concept of the core group, the con-use area is the one that we are looking at. And now it's time that Danilo takes you to our workbench.
Thank you. Thank you, Michael. Good afternoon. Danilo Iovino from Hitachi. I will complete this talk about the meta process. It's important to say that the operational harmonization is a complementary activity, relevant complementary activity for the system, target system identification, and for any intermediate step of the migration plan that will be identified. For this reason, as Michael said, a meta process and a methodology has been adopted from past initiatives and here fine-tuned, just customized. 7 steps, starting from describing the context, including the preconditions, the post-conditions. Then the second step is quite important in ensuring the alignment with the system architecture, identifying the actors and describing their capabilities. It's a thing that is in general also common to many, let me say, all operational scenarios in the end. Then steps 3 and 4 addresses the real description of the specific scenario, nominal and degraded conditions. And here we have the fine-tuning of the meta process, the adaptation, done respect to its original formulation, addressing national specialties not in a separate step further in the sequence, but really in this step, in this phase, with the aim to state that this is important because we need to avoid as far as possible, eliminate the national specialties, because that is the point where the harmonization can fail. Then the work can continue, can be completed. Recommendations are formulated from this work, motivations, recommendation for the system specification itself. Then the document is completed with a formal editing to be proposed later on for becoming a future TSI. Final important step is being sure that this, to take inside the opinion, the needs of the actors that will use this proposal. So the Association of the Railways and the European Railway Agency need to be involved and to review the proposal, the proposed procedure. Here we can see an example that is quite interesting for me to present because I'm leading still today the onboard train integrity in the shift to rail. So happy to see an harmonized way to describe this situation. On one side, we can see the actors, two systems, trackside train, and human actors, some of them involved in the grade of automation 2 only. So the key way to describe, to show, and let me call a use case, because I grew up as also a software engineer, so I was used to design, to implement use cases, and it's useful to have a methodology which is common to all the actors to describe, using quite simple, in the end, a flow of information exchanged among different actors. Green in case of nominal condition, red degraded situation. So quite simple description to state loss of integrity implies informing the human actors, the blue envelope. Then the trains, the injured one, the approaching ones need to be stopped, trackside react, field elements in front and in the rear are no more occupied, are released, and then the trackside system and operator are involved to replan the stopped approaching trains and to arrive to, let me say, repairing, sending the injured train to a location for being repaired. It's important to remark here that this work needs to be aligned with the architecture also from a functional point of view. Let me quote an example that was also yesterday quoted. It's under discussion today whether also this new functionality, virtual coupling, quoted sometimes during this conference, could be also hosted in this case. The Shift to Rail project identified a list of scenarios, and it will be interesting to evaluate how it could be hosted and how it could be designed, described with this now standard methodology. So this is the topic on the table of the next workshop that will be done inside the system pillar ramp-up for the architecture. And I will present this topic internally because I lead this working group in the Shift to Rail. So in the end, this work will be completed by July in terms of making exercises of this methodology, of this meta-process. Couple of examples with nominal train mission, with degraded situation like loss of integrity. So this work will be hosted in a simple deliverable that will include also the experience of using in a couple of examples this methodology. So that's all from our side, and thank you for your attention.
Yeah, thank you very much, Michael and Danilo. This sounds really convincing. And, well, bottom line, as far as I understand, is, well, it's not the intention to harmonize the past, but the harmonization is about a target architecture. And, of course, this is a different setting because then the discussion is a different one. Good. The next topic fits perfectly well to this because George Kapadouzos from ERA will report us briefly about the outcome of a workshop. ETCS trackside engineering rules and effect in operation. I like to say I valued very much George's contribution when we worked in links for rail, shift to rail on the topic jointly together. One of the documents were mentioned there on the slides, so that's a continuation. And I always found George very well motivating and committed to work on the topic. Thank you very much.
Thank you, Klaus. Good afternoon, all. I indeed believe that my short report will nicely complement the presentations of my predecessors. So, workshop 10 was about the ERTMS trackside engineering and its effect on operations. In this workshop, we explored how trackside engineering affects the driver's experience when running on ERTMS lines. We identified several engineering choices that directly impact the driving experience. Some examples we found: whether the trackside is engineered to provide track conditions. Depending on whether it is providing such track conditions, the driver may rely on DMI indications rather than have to look for this information otherwise. Another example, whether the trackside implements the LX procedure of ETCS or any other equivalent solution as the one presented by my predecessors to warn the drivers when approaching a defective level crossing. Again, if the driver gets this information through the DMI, he or she can rely on this without having to look for this warning otherwise. In the process of identifying such cases, we realized how important the human and organizational factors are to the driver's tasks. Indeed, we came to the conclusion that they should be integrated in the trackside engineering by taking the driver's perspective into consideration. I realized that their voice, the driver's voice, has not been heard much during this conference, and yet they are the main end users of ERTMS. The signalers' views should equally be considered. Drivers, members of ALE, confirmed the importance of harmonized operational landscape, if we can call it like that, to their daily tasks. Such a landscape requires at least some basic engineering harmonization to achieve the necessary operational interoperability. Engineering harmonization will also bring along additional benefits like time and cost savings due to less project-specific requirements, and not least important, streamlined verification of TSI compliance. For the time as a substitute to a harmonized trackside engineering, ERA will at least ensure that the information of how the trackside has been designed will be made known to the drivers by means of a new Appendix D3 to be introduced under the OPE-TSI 2022. This appendix will list information that cannot be otherwise known to the RUs so that the drivers can be better prepared. A substantial work on engineering harmonization has already taken place thanks to the engineering support group of the users group in the form of a set of engineering guidelines which are publicly available free of charge. These guidelines are proposed to be included in the CCS-TSI application guide as a first step towards their potential adoption. Harmonized marker boards are also about to become mandatory under the upcoming CCS-TSI 2022, and this is another step in the same direction. The main conclusion of Workshop 10 is that the importance of engineering harmonization should no longer be overlooked. The time has come to agree on more common engineering rules. ERA and the users group are here to support this initiative if the sector agrees to it. Thank you.
Thank you, George, very much. And well, Michel, you positively should note that EOG was was mentioned here positively. Yeah. Yeah. So we are a bit beyond time, 10 minutes beyond, but there is enough time for Q&A. Okay, by the way, the light is now on because nobody should be able to hide. Yeah? So first I would like to welcome some questions here from the auditorium. There's somebody. Okay.
I have a question for the colleagues from Spain. Yesterday we heard that the funding of overlay tracks is not something you want to do anymore. Will it influence your decisions? And the second question is rather technical questions. Are you using linking with your level 1 projects?
Well, first, I don't think that the funding considerations could affect our plans. Some other considerations could do. And linking, it depends of what do you mean, in general or in this for these purposes?
For your level 1 tracks, are you using a linking list?
Well, I think the answer is yes. It's not limited supervision. We are talking about full supervision, if this is what you are asking.
Okay, thank you.
Yeah.
Carlo.
Thank you. I have a question for Ralph, because what he presented about hybrid level 3 is, I think, opening a lot of questions about the future of innovation. If I look at hybrid level 3, and I want to challenge you, let me do this. I would say hybrid level 3 is an excuse not to trust new technologies and keep some part of the existing that we know is solid and is working. And maybe the solution is another one. So if I would be an operator, I would say, or an infrastructure manager, I would say, which is the cost of keeping an hybrid level 3 and which are the benefits we lose compared to go directly on hybrid level, on a full level 3, and which is the maybe technological solution that we can introduce instead of keeping the, let's say, trackside infrastructure or the base that you are discussing. I know it's a bit of a challenge because, but I think this is really where we take the courage to move away from what we know and move in something else. Thank you.
Yeah, thank you, Carlo, for that question. It is a challenge because the technical approach is a challenge, or the technical approach of full level 3. As I pointed out, we need some additional technology measurements as well as a description of operational rules and a combination of safety. Today, we do not have any fallback ideas for the pure level 3. The hybrid is not an excuse. Let's call it, it's a bridge, because we can use the advantages of level 3 or towards level 3, namely increased capacity and accuracy in driving, and we can keep and maintain the safety as with the measurements and technologies which we use today in combination with the rules, and so we can in short term achieve results and have answers on the requests, namely to reduce infrastructure cost. As I pointed out, we need GDS, but in a reduced manner. And we can increase capacity. So this is a short-term achievable technology to answer these questions. You are right, it is maybe not the end of the technology, but it brings us towards the operational problems, which we then can solve by introducing these technologies. Otherwise, we have to go back in the laboratory, think about other technological measurements like train integrity, fallback measurements, and so on. And this will bring us for years in the laboratory without achieving any results. So that is why hybrid level 3 is, let me say it, a bridge and not an excuse. Yeah?
Thanks, Ralph. Michel. I guess the question on the Slido is not yours here, but okay, please.
Indeed not. It's far too technological. I have a question for Yorgos. There was a presentation from Michael and Danilo about the meta process, where they think that they can come to operational, a higher degree of operational harmonization. I'm interested to hear your view on that. Do you agree that this is the right way to go forward, or are you very skeptical about that? So that's my question to you.
I think that this approach will bring benefits if combined with the RCA concept of reference architecture. What we try to do takes the current specification for granted and does not explore the possibility of what RCA are looking for. I think there is potential in this approach. We already have some cooperation on this field to exchange some views, and I expect that we foster this cooperation further in the future.
Thanks, George. Other question from the auditorium? If not, I could give you some time to think about, because there is an interesting question here in the Slido for Jens and Christian. Food for thought. Did Thales and BDK consider the engineering guidelines for the EOG when designing level crossing protection through ETCS?
In general, we are quite aware of the EOG guidelines because we are one of the authors of the guidelines, so yes.
That's the perfect answer. Okay. Again, to the auditorium, where is the raised hand? It's difficult to see. No? Okay. Good. Another. You need some more time. Good. That was Thales. Oh, hot question for our Spanish colleagues. Did you read the question already, Jaime? Should I ask you? Well, I will. And you are brave.
Go ahead.
Is ADIF aligned with the commitment of decommissioning Class B system ASFA?
Well, indeed, to explore the possibility of using ERTMS also for low-density lines is part of a strategy for trying to, little by little, equip all the network with ERTMS and start forgetting about Class B systems. But this said, we also agree in general terms with the goal of the decommissioning, but to be honest, we have to say that it won't be an easy game, neither in Spain nor in Europe, because rational timeframes and considerations should be made. Just as a friendly reminder, some of the reasons Class B are installed come from safety recommendations for NSAs. So, to make a long story short, I think it's a good idea to stop thinking about Class B systems, but it won't be able to decommission them overnight.
Thanks, Jaime. So no, you had a bit more time. Yeah? So, where are the questions? Oh, well, great.
Yeah, Tom Godfrey from Arup. This is a question for the colleague from Siemens with the ATO trial. I just wondered what radio system did you use for the ATO? Did you use GSMR or did you use something different?
We used GSMR for that.
And did you have any, with the use of GSMR for ATO, do you foresee any problems with bandwidth? Do you have any thoughts on that?
Well, for ATO itself is not safety relevant because we have the underlying ETCS system, and the bandwidth for GSMR seems to be sufficient for that to transport the speed or journey profiles to the trains.
Okay, thank you.
Okay, one last question. There's a gentleman with a blue shirt.
One question for Siemens about the hybrid L3 solution you are suggesting. Is it a bit against interoperability concept? No? You don't see this way?
I do not think so, because for the ETCS movement authorities and the movement under the ETCS regime, we just use the specification as it is foreseen in ETCS. It is just an optimization with the legal C system below. Yes, you have to do an engineering for these virtual block sections, yes, but in the final end, the communication towards the train is exactly that what is specified in the ERTMS. So the onboard unit is able to run on that lines today also already. And therefore it's not relevant for, or not against interoperability.
Thank you.
And perhaps the final question, because I need some time for the conclusion. Doesn't seem to be the case. So if you allow me, I want to conclude a bit the session here. Overall, I would like to value very much each and every presentation, but try to combine them somehow in one picture. So comparing to past congresses, I think the focus is not any longer that much on interoperability, safety, which is of course an important feature of ETCS. More and more we think about and consider the additional features which bring added value in terms of cost efficiency, performance. Yeah, and this is something which including harmonization of operation as the basis and the fundament for improvement. So it's more about optimization of ETCS, and I think this process has started, as we could see today. It's not already finished, but at least it's a starting point, and it's from my point of view promising to look into the future. I think the system pillar will help us more to evolve here, but it's a good basis, and I'm happy to see so many committed colleagues to work on these topics. So finally, I would like to also ask you all for a very warm and engaged applause for our auditorium. And thanks you for your questions. The coffee break, long awaited, until 15:50, so please be back in time at 15:50.